Welcome to the Frank J. Meitz Maintenance Management Institute, henceforth referred to as the Meitz Institute. The mission of the Meitz Institute is to provide maintenance management professionals like yourselves our latest and modern maintenance management techniques through my various series of seminars. In each of these seminars, we will address specific maintenance topics from fundamentals to management applications that you can use on the job immediately. This seminar is entitled Preventive Maintenance, Design, Organization, and Management. This seminar will teach you how to design, install, and maintain a PM program. It is not designed to teach you how to maintain a piece of equipment through either changing spare parts, lubrication, the cleaning of the equipment, or the analysis of the safety and health of the operation of the equipment. When we get through with this particular seminar, you should be in a position to design, install, and maintain a PM program. All of the data is in the notebook in front of you. And if you would please turn to page, well, there's no page number, it's an index, excuse me. You will notice that there are 9 sections to this particular program. Let me merely walk through these 9 sections so that you can at least mentally prepare yourself for the various topics that are an integral part of this PM program. Section 1 is an introduction to the maintenance management program itself. Many people have a misconception as to what comprises the maintenance management program. We will define our interpretation for the maintenance management program, and incidentally, we have been using this interpretation for over 30 years, working with hundreds of different companies and thousands of maintenance personnel. Section 2 is the introduction to PM, and we're going to get into the basics of what is required to develop and maintain and install a PM program. Section 3 is going to address one of the 2 major planning activities, and that is craft capacity planning, or some people refer to it as labor planning. Section 4 is the other major planning activity, which will address the spare parts. And here we don't have a capacity plan, but we do have what is called an inventory management program. So the 2 major planning activities, labor and spare parts, will be covered in sections 3 and 4. In section 5, we will show you how to establish the planning and scheduling activities and provide you with some ground rules relative to how far out in the future you may want to plan, and also how far out into the future you want to schedule. Section number 6 is the reporting relative to the PM program. And we talk about reporting, we're addressing the craft labor reporting. We are also going to talk about machine operator participation in reporting, and even to the extent of where we may use outside contractor support. Section 7 is the financial analysis of the entire PM program. And we're going to, in that section, discuss the different types of data, the different reports that you may want to consider to not only monitor the effectiveness of the PM program, but the return on investment for a PM program. Many of my students and also companies that I have provided services for say, what will it cost me to establish a PM program? The answer, if it's done right, is nothing. The three major returns on PM are as follows: an increased utilization of craft labor, the decrease of inventory investment, which means the savings annually of inventory carrying cost, and the third, which is probably is equal to the first two, is an increased utilization of the company assets that you are going to maintain. In section number 8, we're going to look at some of the data elements in predictive maintenance. Predictive maintenance is an enhancement to the PM program. And some companies, when they institute PM, and it's a gradual building block going from, let's say, a department or a machine center or a cell or a focus factory, moving from one to another. At the same time, these companies would introduce some form of predictive maintenance. So we will go through some of the building blocks and the requirements of PDM, predictive maintenance. In section 9, the last section, we'll address TPM, which is total productive maintenance, and that is, again, an additional enhancement of PM, where machine operators for, let's say, machines, or truck drivers for over-the-road vehicles, or forklift truck operators, and anyone else who is utilizing assets within the company to perform specific tasks, giving them the opportunity to support the maintenance management program by actually performing some PM activities. So without further ado, we will now go into section 1. Page 1 of section 1 indicates that there are 6 types of maintenance management programs. Now, these 6 types are a byproduct of my 30-plus years of experience in providing maintenance management, educational programs, and for companies, like I said earlier, maintenance management training sessions and services internally within a client organization. On page number 2, I have identified those 6 types of maintenance management systems. The first is reactive maintenance, which is basically firefighting, no planning whatsoever. The second is proactive. We're doing some planning and scheduling, but not across the entire organization relative to the mission of the maintenance organization. Now, the third one is preventive maintenance, and that is the subject of this particular seminar. Preventive maintenance says full planning and scheduling. So whether you are number 1 or 2 above, the byproduct of this program is to provide you, as I said before, with all of the knowledge and the resources so that you will be a full-fledged PM operation. Now, as you install predictive maintenance, which is 4, and total productive maintenance, which is 5, and as I've said earlier, then these are the enhancements to the PM program. And the last one, which I identify as world-class, and that is where you actually integrate the maintenance planning and scheduling with the production planning and scheduling system. Without having PM, the third type of a maintenance management program, in place, it's going to be very difficult for you to move from 3, add 4, add 5, and ultimately reach what I call the world-class organization, which is 6. So we encourage you to start slow, developing a PM program, and it's our job to provide you with the tools, as I've said before. Now, in page 3, I have listed what we call the 9 functions, the 9 elements, or when you computerize maintenance, utilizing computerized maintenance management system, CMMS. These functions become what we call modules, and these modules are totally integrated. So let me just walk through these particular functions with you, because they must be in place to design, install, and maintain a PM program. The first function is a list of all of your assets, the spare parts that are required to maintain those assets, and all of the maintenance requirements relative to, likewise, maintaining the assets. Item 1 is the heart and input of the PM program. The second function is the equipment spare parts where used list, and that merely indicates for a part all of the different assets that that part is used in. That particular function is used to develop the type of safety stock you want to generate for future unplanned requirements. PM is a planned requirement. It is also used to process engineering change notices for spare parts, and likewise, it is the input into an obsolescence program. The third function is inventory management. This is the inventory management, or you may refer to it as inventory control, for spare parts and all other related materials that are required within the PM program. Function 4 is the purchasing activity. And purchasing really gets its demand, if you will, its direction from the inventory management system. The more you plan PM, the less inventory you require. However, we must integrate the vendor supply chain to support the PM program. And this is one of the main missions of the purchasing activity. If you don't have full-time dedicated purchasing, one of the key requirements is to have that particular activity supporting the PM and likewise the maintenance management program. Function 6 is craft capacity planning, and that is the second of the major planning activities that I alluded to previously. The first one, again, inventory management, and the second is craft capacity planning. The 7th function is the maintenance work order and planning system. You're going to gradually move into planning and scheduling. And at some point in time, and from our experience, it may take you a year, maybe 2 years, if not longer, depending upon the size of your company, the various types of assets that you have to maintain. It will take 1 to 2 years to completely install the PM program, where you have 100% coverage of the PM activities for all assets. The 8th function is the maintenance work order reporting activity, and that is the reporting by craft, labor, and as I indicated, it could be also encompassing machine operators and outside contractors. There are 4 elements that we will discuss relative to reporting, but let me at least address those now. The first element is time on the job. The second element are the observations. The third are the findings of that craft person when he or she is performing the PM activity. And the fourth, which is extremely important, is the recommendations for operating improvement. And operating improvement does not lend itself to the asset itself. We may have to change around the sequence of steps on the PM work order. We may have inadvertently omitted a step. That would have to be added. Maybe we have a step or two that should not be on the work order. So the two major byproducts of labor reporting is the utilization of the machines, that is increased utilization, and to make certain that the PM data on the various PM documents are accurate. And last but not least, we're talking about the financial analysis of the entire maintenance program. Now, moving to page number 4, what I have done here is addressed the same 9 functions, but here we're showing you how they are integrated to support preventative maintenance. You'll notice there's an arrow coming out of item number 7, and it is going up to item number 1 on the left-hand side. That arrow is what the planner scheduler addresses relative to what are the PM requirements for a specific asset. And again, that would include the labor requirements and the spare part requirements. The little arrow coming out of the right-hand side of 1 going to 2 is how the second function, spare parts where used list, is developed. There is another arrow coming out of 7 on the right-hand side, and it is going up to the inventory management section, and that is the spare part requirements for the specific PM work order. The arrow from 7 going directly up to capacity planning in the center of the page is representing the labor requirements. So what we have basically done here is we've totally integrated the planning and scheduling activity, addressing the asset, the spare parts, and what PM activity is required. We have coupled the inventory management program relative to spare parts requirements into that planning and scheduling function, and we have likewise integrated the craft capacity requirements for that PM activity. And as I said previously, the PM work order generally addresses labor and spare parts, so that this exhibit demonstrates how these functions are interrelated. If I must purchase spare parts, then you'll notice there is an arrow coming out of inventory management in the center of the page going directly to purchasing. And these are the purchased requirements for planned maintenance orders. In this case, we are actually cross-referencing the planned maintenance PM work order to the purchase order, and likewise the purchase order to the PM work order. When material is received from a supplier into the storeroom, which is indicated by the arrow coming out of 4 to 5 on the left-hand side of the exhibit, that represents the receipt of material. That material was purchased for planned maintenance requirements. So the storeroom is going to support not only the receipt of the material, they also account for record accuracy relative to the vendor shipment. They also do receive an inspection and then apply that material to the maintenance order. And if the maintenance order has not been scheduled and released, then that order will be housed in a bin location, and that area we generally refer to as PM orders waiting to be scheduled and subsequently released to the various craft personnel that will execute that order. There's an arrow coming out of 7 to 8 in the center of the page, and that is the actual issuance of the order to specific craft personnel. Now, there are 2 arrows that come out of number 8. One, it's going back to 7, which indicates the reporting activities, such as the time on the job, the observations, the findings, and the recommendations for overall operating improvement or changes that may have to be considered relative to the PM work order itself. Coming out of 8, on the left-hand side are the data elements that are converted into financial terms, and that's how we effectively track the effectiveness, if you will, of the PM program itself. So what we're providing you with is a detailed roadmap of the interrelationship of all of the 9 functions within the maintenance management program and how those 9 functions support PM. When the planner scheduler is going to develop a PM program for a particular asset, the questions that he or she are going to ask are identified on page 5. And we will look at the same data, the same questions in other sections in a notebook when we get to the planning and the execution of that plan. But basically, since this is kind of an introduction to the maintenance management program, I merely want to address these items for you in terms of data interpretation. One is, what will we maintain? Well, what asset are you going to be working on? What must be done? That's the PM requirement for that period of time for that particular asset. How long will it take? Well, that's the cumulative time that was developed for the PM activity itself. How often will we perform the task? That's a frequency code. And as you'll see a little later, there are 4 different frequency inputs. One would be a shop calendar, another one would be machine hours, a third one would be odometer readings, and the fourth one would be the input from the predictive maintenance program. And again, as I said a moment ago, we will address these issues in greater detail in the following sections of the notebook. Who will perform the task? Well, who's going to do the work? Is it going to be maintenance craft personnel? Is it going to be machine operators? Is it going to be, let's say, a contractor, or maybe a combination of all? And that is a question that has to be addressed by maintenance management. And the last question, number 6, addresses the basic physical requirements of the work order. What spare parts are required? What special tools and equipment are required to perform the task? And are there any special documents that the craft person or other people performing the PM activity may require? So these are 6 key questions to support not only the development but the maintenance of the PM program itself. Now, there are 2 types of planning and scheduling relative to supporting the PM program. On page number 6, we are addressing internal planning and scheduling. This is done by the planner scheduler, and the data elements that he or she will utilize, starting with 1, and incidentally, these numbers do not coincide with the 9 functions of the maintenance management program we previously reviewed. But these are the data elements in some succinct order that the planner scheduler would use when he or she establishes the PM program for an asset. Again, we start off with the equipment, the spare parts required, and the type of maintenance activity relative to PM. We plan, and then we ultimately schedule the order. We require craft capacity planning. Don't forget, this is internal. Externally, we may need, let's say, some contractor support. We issue schedules for the work orders so we can look out into the future and determine what our workload is relative to capacity requirements. And then after the work is actually accomplished, we will develop the financial analysis for this internal planning. Now, simultaneous to this internal planning, if you turn to page 7, we have what is called external planning. This external planning is through the inventory management, the purchasing, and the storeroom or the crib. And here we're using the vendor base. Again, we're looking at the same element, item 1, that the planner scheduler did when he or she started to plan the PM work order using internal planning. Here, if there are items that have to be purchased, we're going to support the inventory management program through the purchasing system. Now, I do know that some of you probably manufacture your own spare part. So in this case, purchasing wouldn't get involved, but a work order would be issued out of the inventory system and be moved over into the operating schedule so that we could plan and schedule those spare parts based upon its time period and due date into the maintenance operation, so we can commingle those parts, whether they're manufactured or purchased, to support the scheduled date of the PM order. Once the planning of purchasing has been accomplished, we follow up the vendor, which is step number 5. The next 2 steps are integrated into 6, which is the receiving and the receiving inspection. And then if the material is required to be housed in the storeroom for a short period of time, it's put into that maintenance PM work order staging area that I addressed earlier. And 9 is developing the financial analysis of that external planning. So if I take the internal planning, the external planning, and I commingle them, I have now developed one single PM program. But again, you have to recognize internally we plan labor, externally we plan the spare parts requirements. And incidentally, just for your general edification, with all the companies we have worked for and the training we have done with thousands of other company personnel, 99+% of all items, that is spare parts, are purchased. And I want to bring that up at this time because before I said PM will not work if we do not have full-time purchasing support. I think between page 6 and 7, it becomes quite clearly that you cannot isolate the vendor supply base from the PM program. It has to be commingled directly into the PM program right at the PM work order inception. And without that, the PM activity is not going to work according to the way it is going to be designed. Now on page number 8, we're addressing the 4 major planning activities. Everything starts with planning and scheduling of the maintenance PM order. We have inventory planning of the spare parts. We do the purchasing planning. Now in item 1, we are also doing craft capacity planning. And then item number 4 are the storeroom and warehouse management requirements to support PM. These 4 planning functions must be in place before you start PM. They require full-time support. Now remember, I didn't say they require a person in each activity. They require full-time support. In a small organization where I may have 20 or less craft personnel, and that's my definition of a small company, the capacity plan is very easy to develop. And in the planning of inventory and purchasing, I can put those two activities together and have one person do both. In other smaller organizations, planning steps 2, 3, and 4 on page 8 are done by one person, and really the maintenance work order planning and scheduling is done by a supervisor. Now, as I get into the medium size and the larger organizations, I have several people supporting each one of these activities. So everything is relative to the size of your maintenance organization and the number of people required to support these 4 activities. But again, my advice is please have these 4 activities properly staffed by 1 or more people. And as I've indicated before, one person could do more than one of these functions. But they have to be in place before PM becomes an effective program. Now, the next series of pages demonstrates organizationally how these activities actually work together. This is a little more detail than we went through where we looked at those 9 functions and we showed the integration by the arrows and lines. So on page number 9, we're addressing 5 major planning activities: inventory management, capacity planning and scheduling, the work in processes, the labor reporting, then the purchasing and the warehousing. So if you turn the page, and I'm going to walk you through that bottom maintenance organization. And remember, these are functional requirements. Again, they do not need individual people to support each function unless you are large enough where you require the support. Starting at the left, we have inventory management. Then we have capacity planning and scheduling. The third one is the work in process control, or what we call the labor reporting. The next we have warehousing and stores. And then the last one to the right is the purchasing. Again, these particular functions are a byproduct of those 4 activities that we addressed in page number 8. Now, moving forward to page 11, we're going to show you how these items, these functions, I should say, are integrated in some of the basic data elements that are going to be required in order to have a successful PM program. The first one is entitled Inventory Management. Now, the inventory management program must have an inventory document for each and every spare part in the entire maintenance organization, which also would include things like lubricants and cleaning media, filtration media, and so forth. The key is that the inventory system must track both planned and unplanned requirements. And therefore, that box down at the lower portion of this exhibit demonstrates planned requirements and unplanned requirements. Right now, you probably may not be doing any planning, but as you start to move into the PM program, percentages of the total unplanned requirement today are going to be converted over to planned. The inventory record has to be designed by part number so it will track by recording the requirements of planned versus unplanned. Going back to a comment that I made a few moments ago about the 1 to 2 years to install a PM program. Once you've completed the development and implementation of your PM program, you're going to find that there's going to be a ratio between planned work orders and unplanned. The most common ratio that we have seen for non-continuous manufacturers is 80% of all the work orders are planned and approximately 20% are unplanned. When you're in a continuous process industry, you're going to be able to determine that your planned requirements are going to be up to 95%, if not more. And that will come over a period of time, but you'll never be able to develop that percentage without the improper, inventory recording system. So again, let me emphasize, the inventory record for each and every part number must track both planned and unplanned requirements. Now, the byproduct of the inventory system is twofold. Item A indicates that we're going to commingle, if you will, the spare parts requirements with the planning and scheduling activity. And item B indicates that if I must purchase an item, then that is a purchase requisition requirement going to purchasing that has on it the planned maintenance work order, the date that it is required, and any other pertinent information to support the purchasing activity. Now, moving forward to page 12, we're talking about capacity planning. And one of the key data elements that are required is that box in the lower center of this exhibit. We talk about maintenance operation standards. This is not an industrial engineered document or record. It is the standards that you're going to develop relative to estimating how long it's going to take a craft person to perform a particular task. And you're going to find that one task may be applicable to other tasks for other assets. I advise you to start generating these operating standards. You could call them work order standards or craft operation standards. I don't care what you call it, but be consistent. Start to record the standards. One easy standard to start developing is the travel time for a craft person from, let's say, the maintenance shop out to a particular department or to a particular machine. The travel time back to the maintenance organization. Other standards would be developed relative to the first step or the first operation or sequence on a PM work order. We call that preparation time, and that is the time to get the necessary spare parts, tools, equipment, and documentation from the crib. So you can see that you are in the ability or have the ability to develop the standards, and those can be utilized, as I said, by other PM activities for other assets. And basically what the balance of the exhibit demonstrates is that we are going to feed back inventory requirements for items that may be on the PM activity that were not developed by inventory management. We also are going to have some schedules. We're going to have load reports. We're going to develop the PM work orders themselves that will be used by maintenance craft supervision. So what we have developed here is the capacity planning and scheduling function relative to that activity to support PM. Now, moving forward, we have work in process reporting. And basically, this exhibit ties together the warehouse to support the issuance of the work order to the individual craft personnel. We'll get into how that support is developed in greater detail in a later section. We also get into craft capacity and scheduling, where we may have to make adjustments to the craft plan or to the schedule based upon availability or the non-availability of craft labor. But again, the reporting here is fourfold: time on a job, observations, findings, and recommendations for operating improvement. And moving forward now to the purchasing function, you could see that purchasing is directly commingled with capacity planning and scheduling. That's the PM work order. It's tied in with the supply base through the issuance of purchase orders, which is I. And then also it is tied in directly with the warehouse, the storeroom, or the crib, whatever you call that specific activity, through the receipt of materials. That is the accountability of the quantity that we receive from the supplier, the quality check through receive and inspection, and then ultimately applying that receipt to the individual PM orders. And the last exhibit in this section pertains to warehousing and stores. And if you look at that very large, elongated box in the center of the page, that merely demonstrates the different activities that are involved with the storeroom and how material is received from the vendor. There may unfortunately be some rejects, so item 9 is a return to the, not 9, but N, excuse me, is a return to the vendor, and where we actually are issuing material against the work order O, and then ultimately the return of any unused material or the return of equipment or tooling or documentation, which is covered by M. So again, if you were to take these 5 exhibits, and I encourage you to do this, make copies of them, and put them up on a pegboard. And therefore, you can see the complete integration of the maintenance management program by all of the individual functions. I would also encourage you to make a copy of page number 4 and also put that on top of these 5 documents, these 5 pages that we just went through. The page 4 is going to identify the 9 activities or functions within the maintenance management organization, and the 5 will actually show you the integration of those activities through additional data elements and terminology. Those 5 documents plus page 4 are excellent documents to use as training aids to train maintenance personnel on really what comprises a PM program. So what we'll do now is to move into section number 2. In section 2, we're going to walk through what I call the introduction to the PM program. These are going to be some of the building blocks that you're going to have to go through in terms of understanding, so that when we're through with this section, you should be in a very comfortable position to understand how a PM program is actually designed. On page 1, we identify the basic definition of PM. In industry, many people, and especially in the maintenance environment, feel that PM is a lubrication or a cleaning system. This is not the case. There are 4 different activities associated with the PM program. One is the changing of spare parts based upon some frequency code. Second is the lubrication of equipment. Third is the cleaning of the equipment. And fourth is the development of the safety requirements in terms of operating that equipment. We have taken the PM program and broken it out into those 4 functions. The reason for that is at some point in time, and you'll see we have the same requirement for you, for your consideration in a notebook. Can people outside of the maintenance organization perform any of those 4 tasks? And I think the answer is quite obvious. Machine operators could lubricate, they could clean, and they could likewise perform safety and health checks on the equipment. And that gives us the ability, therefore, to enhance PM through the addition of predictive maintenance and also through total productive maintenance, again supported by machine operators. So with that understanding, we want to take a look at this basic definition, and basically what it says is we're periodically going to inspect the plant assets. And that inspection is not just a visual inspection. If we're using predictive maintenance, we're going to be inspecting through diagnostic tooling. If we have machine operator support through TPM, we're going to have the input from the machine operators. When a maintenance person goes out on a job, remember the 4 data elements of reporting? Well, I'm going to talk about the last 3. Observations, findings, and recommendations for operating improvement. That is basically what the periodic inspection entails. The upkeep of plant assets and equipment to rectify a condition that could be injurious to the equipment or asset is really what the second paragraph is addressing. If we move to page number 2, we're talking about the principal functions of PM, and they are to perform the activity, to detect potential problems, as I've indicated before, and to report observations, findings, and operating improvement. Now, you may ask a question. Why is page 2 in the notebook? Isn't that part of page 1 and some of the dialogue that you just went through? Yes, it is part of the previous dialogue. But the reason that I've instituted page 2 and inserted it in the notebook by itself is as follows. Who can detect potential asset problems? It certainly cannot be done by an apprentice. It has to be done by a journeyman or another individual within the craft organization that has the experience. As you install PM, you're going to install PM on a step-by-step basis, utilizing just a few people to get started, and then you gradually are going to add additional personnel to the PM program. That's one of the reasons it takes 1 to 2 years to install PM. We want to start off properly by using some of the best skills, the best talent that we have in the organization. And once the program gets started, these people could train other people to become as skilled as the individuals that first started the PM program. Without the proper experience and the previous training and knowledge of your equipment and your assets, PM will not be introduced properly. So again, just let me reiterate what I've indicated before. We want to start off with skilled tradespeople and then ultimately bring additional personnel through proper training into the PM program. The culmination of PM is defined on page 3. The PM program should be detection and results oriented. And again, You can't do that with unskilled, untrained personnel. Now, on page number 4A and B, we're addressing some of the questions relative to the development of the PM program itself. Now, you'll notice that the first 6 questions on page 4A were actually addressed in section 1, page 5. But I'm going to go back over those so that we can have the continuity of the PM program as we move from item to item. Again, 1, what will we maintain? That comes out of the equipment maintenance requirements. That would be function 1 within the PM program. What must be done? That's the specific recommended PM activity, recommended by either the OEM of the equipment or the asset, or it's something that you have developed internally through years of maintenance of that particular asset. How long will it take is the timing. How often will we perform the task is the frequency code. Who will perform the task is the identification of the labor. And then 6, we address the requirements of spare parts, tooling, equipment, and documents. Now, number 7 addresses the planning and scheduling documents, reports, and other things that are required within the PM program. So starting off with 7A, we address the requirement of a PM work order. That basically is to plan that PM order. Planning precedes scheduling. Planning can go out as far as your program would dictate. Items that are planned within PM are major and minor overhauls. And in many cases, those could be planned 1, 2, and 3 years in advance. The PM work order itself must be scheduled. Now, the schedule is an actual date that I'm going to execute the PM program. I will address the scheduling activity in greater detail when we get into a future section, but let me at least identify the timing between planning and scheduling now. Planning, as I said a moment ago, you can go out as far into the future as you want. Scheduling, you should go out maybe 1, but no more than 2 weeks into the future. And as you start to move forward in the planning process, then orders that are planned now can become scheduled. So it's a continual program. Plan and then schedule. Then we actually develop the work order data, the PM work order. What's required? And these are all of the steps. Now, the 4 basic steps are preparation, as I've identified before, travel to the job site, perform the actual PM task, and then travel from the job site. Now, in some cases, some companies will add a 5th time element, which is called a contingency for delay, and that is when I'm going to a piece of equipment or an asset to perform a particular PM task. I want to give time to that craft person to go through his or her observations, findings, and hopefully recommendations for operating improvement. Some companies will allow 5, maybe 10 minutes to that particular activity. Then once we've gone through, let's say, 1 year of activities for an asset, then the contingency for delay is removed, and then we go back to the basic 4 time elements on the work order. Step 8 is the feedback required, and that is the time on the job, and then again, observations, findings, and recommendations. Now, you probably may get sick and tired of me talking about findings, observations, and recommendations. That is the capstone to make the PM program function properly. If I went out and perform the PM task. And I saw something that should have some maintenance work accomplished, but I didn't report it. Something is going to happen to that asset, like a machine failure. And if that happens several times, people in the organization are going to feel that the PM program is not providing what the PM program is intended to provide. And that is the longevity of that particular asset. So again, it's going to be important to get the proper feedback from our craft personnel while performing PM activities. Now, there are going to be changes to reports and to records. Item number 9 addresses a load report. The load report is the amount of craft capacity required for future planned PM orders. The schedule, which is addressed by 9B, is the actual release of that capacity required from a load, and we put it into what we call an execution stage. When we get into the section on planning and scheduling, we'll go through the steps and the data elements and show you how that actually is accomplished. Then, least we not forget the machine operators. So that is an element that we've added to this list under item number 10. And again, machine operators can be supported by truck drivers, forklift truck drivers, and other personnel operating other types of equipment. Now, item number 11, what are the costs of the PM program? Well, we have basically 3 types of cost. We have the cost of the labor, we have the cost of the spare parts used, and then the third element is the overhead cost of the maintenance department itself. Those added together represents the total cost of the PM activity. Now, what are the benefits of the PM program? As I've mentioned earlier, there are 3 major benefits. There are many others, but 3 major benefits. The increased utilization of craft labor, the reduction of inventory investment, which reduces the inventory carrying cost, and the increased utilization of your assets. You should establish records to keep track of those 3 types of return on investment. And if we're talking about financial returns, then my recommendation is to get the financial department to sit down with you and develop how they would like to track and record the actual financial return on investment. One of the easiest applications relative to providing financial support is the tracking of running time versus the tracking of downtime. If a machine has a failure and it goes down, the machine is not earning what we called earned burden. Another term for that could be overhead. The financial department could tell you what the lost earned burden is when a machine is down. And the reason for that is when you set up the selling price structure or the cost structure of the items that you're manufacturing and ultimately selling, you know the cost consists of the material cost, the direct and indirect labor cost, but it also has what we call the fixed and variable burden cost. And it is that burden cost that could be extremely high in terms of dollar value, especially where you have assets that are in the thousands and thousands of dollars. So again, to kind of summarize item number 12, we want to have the support of the financial department to help financially track the return of the PM program. Now, once we have developed and understand this outline, then I think the next appropriate question to ask is, what are we going to maintain? And here again, you're going to have to develop your own list to answer that question. But there are many of us in a manufacturing or in a service organization, warehousing, hospitals, food processing, whatever it happens to be. We've got some of these common terms, like we maintain manufacturing equipment, material handling equipment, tool room equipment, maintenance equipment. That's the equipment used by maintenance to maybe repair particular assets. We may have laboratory and R&D equipment, transportation, fire protection, buildings, and generating equipment, grounds. We maintain our grounds. Many of us use outside contractors for that support, and then others as required. The key to the development of and the institution of the PM program is to determine where you want to get started. I certainly wouldn't want to get started on PM on grounds. The return on investment is not going to be as large as if I started, let's say, with manufacturing equipment. And depending on how many pieces of manufacturing equipment you have, you may want to get the input from operations management to support the question, where should we get started? And the more people outside of maintenance that you can get involved in addressing that question, what is the hot button in your particular area? And that's how you get started. And basically what you're really doing is you're bringing these people outside of maintenance, making decisions relative to the maintenance PM program. They become part of the development of the PM program. And this is a key requirement, because then they start to see how that PM program is supporting, okay, the direction that they have recommended that maintenance should move in. Now, when we look at equipment or buildings and grounds and other processes and so forth, some of the things that we have to really zero in on is, what are we actually going to inspect and maintain in a piece of equipment or in a building or in power distribution and so forth. Well, what we've done in page 6A and 6B is to give you a starting point. Motors is a beautiful area to get started in PM. Or controls. Those could be electrical, they could be electronic, they could be hydraulic. Tanks and auxiliary equipment. Electrical systems, hydraulic, pneumatic. Where you are in the area of CAD, CAM, manufacturing applications, you may want to look at the computer systems that are out in the shop. Material handling systems. Those basically allude to overhead cranes, conveyors, in the floor, track systems, and whatever. Robotics is another key area of consideration. Fire protection. And continuing on page 6B, waterline systems, lighting, safety, the heating systems. That would be extremely important for those of you in the northern states, especially as you migrate into the fall and winter months. Refrigeration and cooling systems, and waste treatment. And there are a myriad of other types of activities, functions that are performed in your particular operation. So 17 says there's no list that's ever complete 100%. Add to this. Now what I would do is I would take your list, and let's just assume that pages 6A and B is your list. Put those in the sequence of priority. Put those in the sequence of the way you would like to institute PM. And these requirements should be added to those that we reviewed on page 5, and That will give you the starting point in terms of your craft requirements, and especially those of you that are in a multi-craft environment, and also the spare parts required to support the PM activity. Now, page 7 and 7A and 7B reflects some of the questions that you may want to ask to maybe help you get started in terms of prioritizing the implementation of PM activities. The first question is EMA critical? Now, EMA is an acronym for equipment, machine, and or asset. On a future page, we will address the equipment, machine, and asset nomenclature. Some companies have 3 different numbers for the EMA. If you are in that environment, or you may just have a machine and asset number, you want to make certain that all 3 are in the same item master record, so that when finance asks for asset information, you can go to the appropriate record and pull off all of the data relative to their request. If operations, on the other hand, wants to determine what the maintenance requirements are and costs are for a piece of equipment or a machine, you likewise have the ability in that same record to strip off that information. The second question addresses standby equipment. Now, that doesn't mean that equipment is standing by waiting for something to break down. What it really is addressing is there 2 or more similar pieces of equipment in a department or a machine center? Sometimes if we have a variety, not all the same, but a variety of different pieces of equipment that can basically perform the same activity, that machine center may have a lower PM implementation schedule criteria, as opposed to where we have one piece of equipment very critical to the operation, and that would have a higher priority relative to starting the PM program. Step 3 addresses the age, the condition, and the value of that equipment. In many cases, if we're going to try and install a PM program for a piece of equipment that is not operating up to its full potential or capability, then my recommendation is to develop a major or minor overhaul, bring the equipment up to its standard level of operation, and then institute the PM program for that piece of equipment. Never try to put a PM program on what I call a dinosaur, because irrespective of the PM activities, you're still going to find that that piece of equipment is going to have machine failures. Item 4 is a operating condition question. What's the severity of use? Pieces of equipment in, let's say, steel mills, or in the forge shop or the foundry shop, are subject to severity of use, and maybe those types of equipment would have the highest priority to implement the PM program. Safety requirements is a key issue. Before I'd institute a PM on a piece of equipment that didn't have the proper guards over moving items like motors and belts, or let's say the electrical panels were not the type that could be locked securely, my recommendation is to get the equipment in not only good operating condition, but good safety condition, and then institute the PM program. Continuing on in page 7B, what is the susceptibility of damage to the piece of equipment? And here again, we could be talking about a piece of equipment that maybe is near an aisle or where aisles cross each other, and it could be damaged by, let's say, a forklift truck operator. You may want to consider putting guards around the equipment, other protective features before you start the PM program. It's another method of trying to prioritize how and where you're going to start preventative maintenance. And item number 8 has to deal with those pieces of equipment that can lose adjustment during its operation. Again, the recommendation is to bring that equipment up to operating standards. Additional requirements to consider would be major product or product lines where they are produced, like maybe sub-assemblies or assembly lines, or major customer requirements. Now, where would I get the answers to 9A and 9B? From the sales and marketing department. So if you remember earlier, I said get the input from all of the functional departments in the organization. So the list on page 7A and 7B should support your development of a program so that we can get this type of input from other people, and then that's going to give you a pretty good overview of where and how you should get started in developing the PM program. Remember, it's going to take 1 year to 2 years, depending on the size of your organization, to institute PM. So this is a planning and it is a scheduling system. You're going to plan PM, you're going to plan the development and the implementation of PM, and then ultimately you're going to schedule it. On the bottom of page 7B, I'm addressing that acronym called EMA, E-M-A. And I've kind of alluded to this before, but that note merely says if you have more than one description, more than one part number of an item, get that data into the item master record. Don't have 3 different item master records, because then you have to go through a lot of cross-referencing. Put all of that data into one item master record and then strip off the information that may be required based upon the requestor. Now, item 8 indicates the modularization of either a building, grounds, or pieces of equipment. Modularization is to take a very large piece of equipment and break it down into smaller segments, and those segments I called modules. In a moment, we'll look at a modularized picture of a computerized milling machine, and then we'll take a look at a spare parts structure in terms of how those modules can be then therefore addressed relative to the spare parts that are going to be required at some point in time by the PM program. One of the easiest ways to identify the modularization of a piece of equipment is the paint line. Paint lines could be very, very long. They could be 200-300 feet in length. And if I were to give a craft person a PM work order, and let's say it said, go ahead and lubricate the motors that are in that paint line. The first thing I'd ask myself is, where are those motors located? Modularization defines where those motors are located. Where I have large pieces of equipment that have different functional requirements, like electronics, electrical, hydraulic, pneumatic, and even things like mechanical requirements. We want to address where are those requirements found on a piece of equipment to support two things: the ease of developing the PM program, but most importantly, the ability to direct the craft person to where he or she is going to perform that PM activity to minimize the time element that that person may need to actually find where that activity is going to be identified. Now, at the bottom of page 8, I've given you some cross-references relative to modularization. And what I want to do now is move to page number 9 and take a look at a pictorial diagram. That's the picture that I referred to, and just to show you how modules are identified. Here we have a CAD-CAM application. CAD, computer-aided design; CAM, computer-aided manufacturing. This particular machine is driven by a computerized program, the CAD portion of CAD-CAM. The machine has a number 102. Now, if I look down at the lower right-hand corner, I'm going to address two different modules, Module 01 and Module 02. The module by itself doesn't tell me anything, but when I put the equipment number in front of that particular module number, it now identifies that it is a module of 102, machine 102, and this picture here addresses where it is located. Modules 01 and 02 require electrical support, that is, maintenance personnel that are electricians. When I move to the left of module 01 and move to 03, that panel is really the front panel of the computer program. Now, without the proper training, an electrician may not be able to support the PM activities for that computer application. I may need what we call an electronic technician. So therefore, moving all the way around the machine, each one of these functions is identified by an individual PM program. It is also identified by the frequency of that PM activity, but most importantly, it addresses where that PM person is going to perform his or her particular PM activity. Now, moving to page 10A, this is the diagram relative to that machine 102. And here I've only selected 3 modules, module 1, 2, and 3. But you'll notice that on module 1, which is on the left-hand side of the diagram, it has 2 sub-modules. So the sub-modules are likewise identified by their individual sub-module number, but it does not lose sight of the module number itself. So I'm just going to take one example here, take the extreme left-hand sub-module number. M102 is the machine, -1 is the first module, which is identified right above these 2 sub-modules, and the -1 is the identification of the sub-module. And once I can develop a layout similar to this for complex machines, you don't have to do this on every asset in the organization, but once I can develop the picture that we looked at on page 10, and then identify it by its diagram relative to 10A, I will guarantee the development of the PM work orders themselves and the implementation of the PM activity by craft is going to be sped up, and we're not going to waste time trying to determine where we're going to perform, like I said before, the PM activities. Now, continuing on 10B, I have identified in writing for you, and you could go back over this at any point in time, and it ties together the different modules and submodules that I have just went through previously with you on page 10A. Now, I'm going to go to page number 11 and talk about the 4 PM functions. Remember I said we had inspection, the changing of spare parts, lubrication, cleaning, and protection. So we've taken those 4 and expanded them in terms of what each one of those specifically means based upon a PM activity. Inspection, changing spare parts if there is a spare part to be changed. Examine the equipment. These are the observations and findings. Identify visible defects. Make minor repairs and adjustments if appropriate. Now, here you're going to have to establish the time that a craft person that's performing PM can take to do a minor repair or adjustment. Most supervisors will let the PM person spend up to a half hour to make that minor adjustment or repair. If it's going to take longer than that, then the PM person must get a hold of the supervisor and have another maintenance person come out to that particular job site, which is non-PM related, so that the PM person can continue on his or her PM tasks. It's important to determine at what point should I stop PM, do a major adjustment or repair, or when should I call the supervisor and have additional maintenance management support. This is basically a maintenance supervisor's responsibility. Try and not go over that half hour because you're going to fall behind schedule on the balance of PM activities, assuming that you're scheduling 2 or more activities for 1 PM person per shift. We get into other things like lubrication, determine the proper lubricants, establish the schedule, and then apply the schedule. And the same terminology, the same 3 steps apply to cleaning and the protection, which is the safety and health requirements. Now, if you turn to page number 12, here is where we are addressing, if you will, the PM functions that can be accomplished by machine operators. And we've addressed those before, such as lubrication, cleaning, and then protection through safety and health analysis. Now, there's 2 additional paragraphs on page 12 which are extremely important. They indicate that to support PM, at some point in time, you're going to institute predictive maintenance. Predictive maintenance is going to be covered in Section 8. Likewise, when you're going to consider machine operator participation in the PM program, then we're going to talk about TPM, and that information is going to be covered in Section 9. So the data elements that we're talking about, like I said at the beginning of this program, all of the data elements are within a notebook. And it really is up to you to determine how, where, and when you're going to utilize these data elements. Now, on page 13, we're talking about the planning process. And remember earlier I said we're going to talk about planning and then we're going to talk about scheduling. Those are two separate independent steps, but they're commingled. Scheduling follows planning. The first step is to plan and schedule the plan. That means to establish a date as to when we want to execute that particular PM requirement. In that first step, we are going to consider craft capacity requirements. The second step is if there are spare parts required, then the inventory system has to pick up the spare part requirements. And when I say pick up, it's actually being recorded. And if there are no spare parts available, then the purchasing system supports the inventory system through the procurement process with the vendor supply base. The date in item number 1 or step 1 when we plan that particular order and we attach a scheduled date is going to have to be addressed in both the inventory and the purchasing activities. It is conceivable that the supplier may not be able to have material based upon the planned and subsequently scheduled date. So there's a feedback that has to be developed from purchasing directly to planning and scheduling, where we may have to reschedule the planned and subsequently scheduled order. And then, as we talked about previously, the culmination of all of this planning relative to spare parts is done by the storeroom in terms of receiving inspection, and then actually applying those spare parts to the PM work order. Page number 14 addresses the planning and scheduling sequences. The planning process is done first. I've talked about it. Here we're putting it in writing so you'll never forget it. The planning process may plan PM requirements 1, 2, 3 years in advance. And there is a date associated with that particular planning process. That will give me the ability to develop a craft load. And if you remember previously I said the craft load addresses how many craft hours by craft will be required to support that planned PM work order. When we schedule the order, we're actually going to release the order to the maintenance organization, to those people that have been assigned to support the PM program, and they will actually execute the PM work order in total. And then the PM scheduling process relative to the third paragraph has to be commingled, if you will, or coordinated with the production operations planning and scheduling program. We're going to talk about the need of that step a little later, but those are the 3 major steps. Let me summarize them again. Plan as far out as you want to. Schedule 1 to 2 weeks in advance, no more than that. And most importantly, commingle, integrate the maintenance PM program with the operations production planning and scheduling system. Now, there are some requirements relative to establishing frequency codes. That addresses the question, when should a particular PM activity be done? There are 4 answers to address that question, when. First, we have an annual shop calendar. That's a fixed date. I do certain activities daily, lubrication, do certain things weekly, and then monthly, and semi-monthly, quarterly, semi-annually, and so forth. Those are fixed frequency codes. Where I am tied in directly with the operational requirements of a machine, my recommendation is to have machine hour reading capability. The third would be odometer readings relative to rolling stock. And then the fourth one is through predictive maintenance indicators by using what we call diagnostic meters or other monitoring or measuring devices. Now again, you may have some additional input relative to when particular PM activities are going to be accomplished. So add that to this particular list and then execute the list. We have now covered some of the basics as to what we want to do, when we're going to do it, how we're going to do it, the development of the PM program requirements. Page number 16, we're going to talk about how we're going to take this information and actually apply it to the PM work order itself. So we have some documents here that we're going to go through with you to indicate how the PM activity is going to be developed. Now, it would be nice as to when we received assets, we had all of the PM requirements identified by the asset OEM, the original equipment manufacturer. With all of the analysis that I have done over years with different companies, I think I'm fairly safe to say that 99% of all the people I've worked with do not have that information available. And how sad it is. That data should support the implementation of PM immediately. If we don't have it, we're going to have to develop it. So what we're trying to do here on page 16 is to indicate that item 1 would be the OEM's PM recommendations. That is the beautiful starting point. But if you don't have that information, then you're going to have to look at steps 2 through 5. And that is review, survey the equipment. What do we have to do to get it into condition? We call that review preconditioning. Remember earlier I said don't put PM on a dinosaur. Put a major or minor overhaul into effect and then develop the PM activities. You can look at repair history, which is step number 3. Look at historical work orders. What did we do relative to maintaining the equipment? What spare parts were replaced? And other PM or maintenance activities to support the development of the PM program. Item number 4, if equipment repair records are unavailable, then what can we do relative to reviewing, let's say, historical documentation, like work order orders, the notations that may have been put into some type of a file. 3 and 4 says to me, roll up your sleeves and start to ferret out that information which is going to be required to support PM. Now, another application to consider is to maybe contact the OEM of the equipment. Now, depending on when you received the equipment, some OEMs may have been out of business for years. Others could have been, combined through mergers with other manufacturers. Some may have moved their operation to, let's say, foreign countries. So it's a question of trying to determine, the best approach to get started. You need that starting point, otherwise PM will not be able to be developed properly. Item number 5 is based upon the analysis of maintenance problems and solutions in the past. You should be able to develop some tasks, okay, to perform PM programs. And you can always build on top of that. You can change the frequency codes. You can start to develop the PM activities as a function of running hours of the equipment. Or if there unfortunately happens to be a machine failure and we determine what caused the failure, that would be a perfect input into developing PM activities. Now, on page 17A and 17B are the data elements that you want to consider in a PM work order. Now, I've broken those activities or data elements into 4 major sections. The first section is heading information. And I think if you read this, most of it is all self-explanatory. In fact, I should say all of it is. It pertains to many of the things that we have been talking about. The second major data element is the PM activity information itself. And again, who is going to perform the activity? Is it going to be a machine operator? Is it going to be a maintenance person? Or is it going to be a contractor? Starting off with 13, we have a sequence number. That's straight numeric. What is the first sequence or first step required? What's the second? What's the third? What's the fourth? And so forth. And then again, what are the spare parts required? The special tooling, equipment, and documentation. See, we've covered that before, but now what we're doing for a specific PM, for a specific asset or machine, we're developing the data elements to support that PM activity by itself. Moving over to page 17B, we have the reporting requirement. So there should be on the PM form the capability to record the elapsed time on the job, clock in, clock out, the observations, the findings, and the recommendations for operating improvement. Now, associated with that reporting activity, item number 24 is addressing the return of spare parts that may not have been used on the activity or on the PM program, the return of special tooling, special equipment, and documentation. Those are all integral in terms of reporting. And then the last major function is really the closeout data. Somebody should review the PM work order. Generally, it would be the planner scheduler initially, and then based upon any data that may be very important to the maintenance organization, the supervisor should look at it and sign off on it. We want to therefore develop, if you will, the aggregate time on a job, which is PM utilization, which is item number 27. We want to develop the efficiency of the PM craft person or group, and that is merely comparing the actual time on the job to the, let's say, estimated time on the job. And here, what we're trying to do is to determine whether or not any time elements should be adjusted or changed on the PM work order. And then we develop the PM work order cost, the labor cost, the spare parts, usage cost, and the overhead cost. And again, as item 30 indicates, what additional information do you require? So the PM program and the form should have some basic information, and then you have the liberty to add additional information as required and generally that requirement is a byproduct of the asset itself. Now, on page 18, we have a typical PM work order form. It has heading information like equipment name, the location, the equipment number. The second line going across the top is referencing where this PM activity was generated from, and in this case it was generated from the OEM manual. We have the ability to put the manual number, the page number within that manual, and specification number for this company is the paragraph within the page. And then moving to the third line, we have scheduling criteria like the date issued, the date started, the date completed, who worked on the work order. And then we have some new twist here, and that is the PM sequence number. The PM sequence number is merely counting numerically by one the activities of the same PM application. The first time you do the PM program, you will count it by one. The second time you do it is 2, and the third time is 3. That sequence number helps us to determine whether we're over PMing or under PMing a particular piece of equipment. Continuing to review the PM form, I'd like to address the body of the form at this time, and I'm going to move from left to right on the various vertical columns. The first column is entitled Operation Number, and again, some companies refer to this as a sequence number. It is assigned in straight numeric order in preferences of increments of 1, 2, 3, 4, 5, and so forth. The frequency code is developed from either the fixed calendar or it could be a byproduct of machine hours, odometer readings, or let's say a equipment operating profile which is developed through the predictive maintenance program. In the large portion of the body, we have the actual PM requirements. But associated with the PM requirements would be the various spare parts that may be required, special tools, equipment, and documentation. And you notice all the way over on the right-hand side, there is ample room for PM comments like observations, findings, and recommendations for operating improvement. At the bottom, we have the ability to record who originated the PM, when it was originated, and then if there was someone that was going to proof the PM work order, they would proof it, initial it, and sign off on it. Now, I'd like to make one comment relative to those horizontal lines in the body. You should never have a document that has lines this narrow. This form was designed to be generated with a IBM Selectric typewriter. It would be used to double space the lines, and then the form was fed through a document reader, and the lines were not actually recorded as it went through the document reader. There was a special ink on that particular form. There are different form layouts. We'll look at a few a little later. But this one has some of the basic data relative to support PM. Now, pages 19 and 20 kind of work together, and it represents certain what I call static PMs relative to shop calendar. Static means I'm going to perform something every week, every month, every quarter, and so forth. One of the things that I generally hear out in the maintenance environment is that PM kind of turns into a paper mill. And really, it's not a paper mill. It's because we didn't take the time to add together or commingle, if you will, various activities that have a more frequent frequency code as opposed to those that have a further frequency code relative to time periods. Now, if you turn to page 20, this diagram illustrates specifically what I'm alluding to, and on page 19 is really the outline, the criteria for page number 20. Let's assume that I'm going to generate a quarterly PM. In the quarterly PM should be the weekly and the monthly PMs. And those activities would actually be incorporated into the preparation time, the travel to the job site. Then I would list all of the PM requirements for weekly, monthly, and quarterly. Then I would have travel from the job site, and if there was this contingency for delay, that would likewise be recorded. So you could see as I move toward those PMs that are further apart in time, like semi-annually and annually, what page 20 is trying to provide us with are the guidelines. Generate one PM document, but incorporate those other PMs that are done more frequently. If you follow that recommendation, you're going to find that you will be reducing the number of documents as the various PM activities are developed. Now, that concludes, if you will, the second section in this notebook. And now what we're going to do is we're going to move into section 3, and we're going to address the first of the two major planning functions, and that is craft capacity planning.